Hello everyone. Today we will continue on discussing the last topic which we were having, that is alpha migratory insertion, alpha migratory elimination, or then beta migratory insertion and beta elimination. In the last class we were discussing mainly the alpha migratory insertion, and you have seen few examples with that. But of course all of us get confused about the fact that whether it is migration or insertion, alpha migration or alpha insertion. That is a really difficult or tricky question to answer, because both the migration and insertion seemingly can lead to the same product. Therefore, it was essential for a researcher to come up with a method, come up with an experiment that can distinguish perhaps between these migration and insertion reaction. One such example we will try to discuss right now. Subsequently, we will try to discuss the stereochemistry related issue, what happens when the insertion happens, and whether stereochemistry gets changed or not. Let us first try to take an example where we perhaps will be able to understand whether an insertion or an migration is going on. The query is again the same, whether it is a migration or insertion. Remember, it is a tricky experiment to do, but scientist has done it anyway, where they have taken, let us say, the metal complex with CO. Now, first before getting into the exact experiment, let us try to discuss what will be possible if it is a alkyl migration. If the alkyl group is migrating, that means we have the R group migrating over here. If alkyl group is migrating, then the product that you should expect in this case is this one, right, where R group is getting migrated to the CO. Now, if the CO insertion is happening, okay, starting from the same compound, if we see the CO insertion, it is just exactly the same compound, but written in a different way. Of course, it is again a pentacoordinated compound, and in this case CO is getting inserted into the R. This CO group is getting inserted into the R. So, in the first case R is migrating, that is what the alkyl migration is about. In the second case, we were telling that CO is getting inserted into the R bond. Now, it is again, it is a very tricky experiments to do. It's a very difficult thing to find out which exact thing is going on in this particular case or in any case, because the product is again in this case, as you have seen, from a 6 coordinated one, we get the 5 coordinated one. The product is exactly same in both the cases. Now, of course, there is a subtle difference, or there is some experiment perhaps that can prove the exact nature of this transformation, whether it is migration or insertion. Let's try to discuss a specific example which perhaps can shed light into this trickish problem. The scientist has come up with a complex or a strategy, a manganese complex, and one of the CO is labeled. In this case, one can selectively do these experiments, and very efficiently this reaction can occur. Now, if we were doing this experiment with CO, that means in presence of CO, effectively you will be able to maintain the 6 coordination anyway, right. So, in this particular case, you are expecting to form a series of compound. Okay. First of all, there is a leveled CO, right. So, if it is a methyl migration, okay, if it is a methyl migration, then the product you are going to get is, this is a manganese one anyway, COMe with a star in there. Since we are doing the reaction in presence of the CO atmosphere, of course one can understand that it will be 6 coordinated one, right, and you get these products, and of course you can get another product where COMe is in the axial position, CO. So, these are the 3 different product formation you can expect if methyl is migrating over CO. Now, if methyl is migrating over CO, you can have methyl migration, as you know, cis should be cis to each other. So, one position is possible and this is another position, that is this product. So, and another position is this one. So, this methyl is cis to this carbonyl, that will give you the product, the second one. If methyl is migrating this to this one, that will lead to this product formation, and if the methyl is migrating to this CO, that will lead to the first product formation. So, if methyl migration is happening, all possible product formation include methyl migrating here, methyl migrating there, methyl migrating here, methyl can migrate over there, but methyl should not migrate over here because this CO is trans to methyl and such migration is not allowed, only the cis migration is allowed, right. Now, the product formation pattern should be 1:2:1, and why is that? Because this methyl can migrate over here and here, both these mode will give you the same product, that is why this is twice, this one is one time, that is here, and this one from here to here it is going to be another time. So, 1:2:1 product formation you would expect if it is a methyl migration. Now, the other case is the CO insertion, right. What the product formation will be if CO is getting inserted? Is it going to be the same? Let us look at the compound very carefully and try to analyze in case of CO insertion what is the product formation that one can expect. Let us go back to the compound again, the same compound. Now, imagine methyl is not migrating, but CO is inserting. If CO is inserting, right, so all these, this CO and these 3 CO, all these 3 CO will give you the exactly same product, that is COMe. COMe will be in the equatorial position, right. COMe will be in the equatorial position. Of course, there is a CO. COMe will be in the equatorial position. Now, yes, that is going to be the case. Then you are going to get 3 of these. This CO is traversing here, or this CO is inserting here, this CO is inserting here, and this CO is inserting here. So, 3 of them, right. Of course, another thing that will be possible is CO will be in the axial position as well. In this particular case, this is the leveling one, you will get 1, but this product you will not be able to get at all, because there is no way you can get the axial CO leveled if CO is getting inserted. So, the product formation pattern for CO insertion is going to be 1:3:0. That means, this product formation, that's where CO is in the axial position, the labeled CO is in axial position, and the COMe is opposite to it. it is not going to be feasible if this CO insertion is happening. But when the chemist has done this experiment, they have found that only the 1:2:1 product formation is happening. That means methyl migration is happening, but not the CO insertion. This is once again very tricky experiments to do, and we can have only 1:2:1 product formation. Let us look back at it again. We are having this manganese complex, and 3 different product formations are likely, and for methyl migration we end up getting 1:2:1. For CO insertion, if it is the case, we are going to get 1:3:0, and experimentally what we see is this 2:1 product formation. This is not observed at all. So, this kind of suggests, or as maybe strongly you can say that this perhaps proves, but of course it is nothing in chemistry can be proved 100% guaranteed way, but this is an elegant experiment that suggests that the methyl migration is likely, since this is the pattern observed 1:2:1 or 2:1, this specifically this ratio is observed. Okay. We will then move to the next topic, okay, that would be the stereochemistry. What will be the stereochemistry? We have discussed briefly the stereochemistry in all other previous cases as we were coming along, oxidative addition, reductive elimination. So, in this case also, if we are having alpha migratory insertion, and in these cases at least one component is having the stereochemistry, what will be the outcome or what will be the fate of the reaction in this particular case? Let us try to look at at one of the example, particularly in this case. So, the experiment we are going to look at is stereochemistry of the migratory group. Stereochemistry of the migratory group. Right. Now, again this is an experiment one has to design very carefully, and it is not that it is going to be always very easy to do, but anyway scientist has managed to design a perfect experiment, at least in this case, to shed some light into the problem of the stereochemistry and to get to know what could be happening in this case. Okay. This is an iron complex, as you can see. It is a cyclopentadienyl and dicarbonyl species, and one of the alkyl group, the R group over here, that is having 2 stereo centers, as you can see over here. Right. If you want to put it in Newman projection, you would get simply the tertiary butyl group over here. Let us say if it is in this fashion you want to write, and if you want to put the deuterium, so it should be on the right hand side, since it's the above the plane, and then you have FeCpCO2. This is the Newman projection. Anyway, now if you are reacting this with in presence of triphenyl phosphine, okay, then what you would see is that 2 product formation is likely. Okay. Now, what are those 2 product formation? We would like to have the fact that it can you can have, of course, the the alkyl group will migrate to CO, and triphenyl phosphine will come and coordinate with iron. So, we are not going to write down what are going to be the ligand on iron. It will be 1 PPH3 and 1 CO and 1 CP, and the R group will migrate into one of the CO. We just simply will write this, where we will put that CO is getting alkyl group is migrating, and iron Ln this ligand we are not writing, that would be 1 Cp, 1 CO and 1 triphenyl phosphine, and 2 type of product formation is possible. This is one of them, and another one would be similar, but stereochemistry will be different, as you can imagine. So, 2 possibilities are there: retention of configuration or inversion of configuration, right. In this case also we will put iron Ln. Now, as you can see, among these two products, the first product is having the retention of configuration, right, and the second product is having inversion of configuration. See, the starting material is having D over here, 2 D's over here. If it is a retention of configuration, this is the one. So, I would like to name this as retention. This is retention of configuration, this is inversion. Now, scientist has done this experiment, okay, and this particular compound being synthesized and then triphenyl phosphine being added and treated under suitable reaction condition. What they were able to find is, of course, getting a crystal structure will be great, but NMR can be of help. If this product is forming, you would get from NMR this coupling constant should be 4.5 Hertz, right. If this is forming this 2 proton, this coupling constant would be 13 Hertz. Now, it is a very simple at this point, if you try to look at. So, 2 product formations are likely. One would lead you to the retention of configuration view, the second one will give you the inversion of configuration. The retention of configuration geometry, these 2 proton, as I was highlighting, should have a 4.5 Hertz coupling constant, whereas for the inversion of configuration, the second compound should give us a coupling constant value of 13 Hertz. This is something experimentally measurable, and by synthesizing this complex, scientists were able to do this NMR experiment. By simple NMR experiment, they were able to determine that indeed the first product is forming. That means retention of configuration is happening. That means that 4.5 Hertz coupling constant is the one they are getting. The other one, which is the 13 Hertz one, they are not getting. This again suggests that the retention of configuration, in this case I would say very strongly the retention of configuration is happening during the alpha migratory insertion reaction. It is insertion or insertion or migration. You have seen that the alkyl group is migrating. It is not it is not that CO is inserting, but then again on top of that we have seen that the stereochemistry is retained during the process. Okay. Next, try to move on to the next topic, and that is related whatever we are discussing, and in this particular case we will be discussing that how this migratory insertion is happening in the carbene species. So far we have mainly focused on the metal carbonyl species. We will now look at the similar variation of the alpha migratory insertion, that is the alpha migratory insertion at the metal carbene species. Let us try to take one of the example in this particular case once again. Okay. So, we are looking for a case where a transition metal carbene is there, transition metal carbene is there. Now, the transition metal carbene, as you may be aware of, are these sort of complex, okay, where metal and this double bond are there with a carbon in there. Here you can have some substituent or without it. In this particular case you have 2 hydrogen atom. Now, this is the double bond between metal and carbon. So, this is the metal and carbon bond, this is a double bond, this is what is called carbene species, and let us say on the metal another R group is also present in this case. Of course, metal carbene usually means this is the species, right. You can have different substituent on that. Now, what was interesting, that similar to what we have seen in the CO carbon monoxide case, we can have alpha migratory insertion and alpha elimination. In this case, after alpha migratory insertion, we can get the product MR. If it is the reverse of it, we will get alpha elimination, right. Now, of course, there is a way to figure out what is happening in these cases, what is migrating in these cases as well, whether it is migration or insertion, that is one of the question. Another question that we would like to discuss in the next class is whether the migratory aptitude, that means which groups migrates faster. If you have the competition between two different groups, such as let us say hydride migration versus alkyl group migration, H migration versus alkyl group migration, what will be the fate, which one migrates faster? The migratory aptitude can be measured by experimental pathway. We will try to look at in the next class. So, today's class, once again we will conclude over here, and in today's class we mainly try to focus on the discussion of whether it is a migration or insertion, and then the stereochemistry of the processes, and then we have introduced the transition metal carbene as a component, as a topic where again a migratory alpha migratory insertion is possible, and in the next class we will discuss again alpha migratory insertion, alpha elimination, beta migratory insertion and beta elimination. Till then, see you later. Bye bye.